All right, let's dive right in. When you're talking about radio communications, you know what the name of the game is? Reliability. It's everything. Today we're going to break down the one propagation mode that is the absolute bedrock of stable communication in the MF band, and that's the ground wave.
So where's all this great info coming from? Well, this whole analysis is pulled from a fantastic technical tutorial by the folks at RFI Detectives, who are part of Virtualization Options LLC. Now, this is specifically designed for you, the working RF technicians and engineers out there. So we're going to stick to the core principles you really need to know.
And just so we're all on the same page, this is part 4 of a much bigger 20-part series they've put together. So now that we've got our bearings, let's get into the good stuff. Okay, so the star of the show today is the ground wave. And look, for anyone who works in the MF band, understanding this isn't just, nice to know, it is absolutely essential. This is your baseline. It's the starting point for pretty much everything else.
Now take a look at the official definition, straight from the source. I want you to focus on 2 words here, reliable and predictable. I mean, come on, in a field that's just packed with variables, those 2 words are basically music to an engineer's ears, right?
So let's just break that down a bit. What are we really talking about? We're talking about a signal that is consistent, one whose behavior we can actually forecast with some real accuracy. And it has a very specific physical path. It literally follows the surface of the Earth.
And that idea, the signal following the Earth's surface, that's the core mechanism. That is what gives the ground wave all of its unique and incredibly valuable properties. So let's try to picture what that really looks like.
I just love this quote from the report. It's so descriptive. The wave isn't just shooting off into space, and it's not bouncing off the atmosphere. It is physically hugging the planet's curve. And that is what makes stable, over-the-horizon communication in this band possible.
To really appreciate just how stable the ground wave is, we have to compare it to its much more, let's say, volatile cousin, the sky wave. And understanding the difference here is totally fundamental.
And here it is, plain as day, side by side. On one hand, you have the ground wave, our predictable earthbound signal. And on the other, you've got the sky wave, which is completely at the mercy of the constantly changing, turbulent ionosphere. It's like one is a solid foundation, and the other is trying to build a house on shifting sand. Now hold on, because this reliable ground-hugging behavior, well, it isn't universal. It's a phenomenon that really truly shines in one very specific slice of the RF spectrum. The frequency you're using is absolutely key. And this is the sweet spot. We're talking about the medium frequency band, or MF band. From about 500 kilohertz up to around 3 megahertz, this is the playground where the ground wave is the dominant, most important mode of propagation. Period. Okay, so we've covered the what and the how. But now let's get to the real heart of it, the why. Why is this predictability so incredibly important from a practical, real-world engineering standpoint?
Seriously, think about it for a second. In your day-to-day work, right? When you're designing a system, or you're trying to troubleshoot a link, or maybe plan out a whole network, what's the one thing you need more than anything else? It's knowing what to expect.
And here is the bottom line. Every single calculation you make, every link budget, every frequency assignment, it all rests on having a predictable model for how that signal is going to behave. The ground wave gives you that solid, reliable foundation that you can actually build on. So we've seen it. For the MF band, the ground wave is our steady, dependable workhorse. It's the baseline. But this is just one piece of the puzzle. What happens when the frequency changes? When signals stop hugging the Earth and instead decide to launch themselves toward the sky? Well, that's a whole other story, and it's coming up in the next part of our series.